Good morning, dear students. Welcome to another session of Introduction to Data Structures and Algorithms. So, in previous session, we discussed a program which was related to array traversal and insertion of an element in an array. Now, let us come down to deletion part. So, how we have the logical aspect of insertion, right? In the same way, we have the logical aspect pertaining to deletion. So here what we were doing in the program, so if you remember the previous this thing in session, we had this discussion. So what we did, we moved these elements to one location to its right. Say we increased the index this thing and we moved those elements towards the next position. Now in deletion, what we have to do is, you can observe that say if you're deleting the element at the end, no need to worry, just directly delete this element. But when you're deleting the element in the middle, now what happens is, say suppose I want to delete this element. So in this case, what we do is, you can observe that the element which is present at index location 4 has to move to index location 3. That is, now you have to move it towards left. That is, you have to decrease the index. So similarly, 22 over here, which is having index of 3, has to be shifted to the location which is having index location 2. So this will complete your deletion process. So the logical aspect is same even for deletion process, but the direction in which you are performing the in which you are moving the elements, that differs. So let us see into the logical aspect of, say, array deletion. So here you have declared the array. Here you're printing the array by traversing through the array. Then what you're doing is you are just asking the index location. You're just asking the index location of the element which has to be deleted. So previously, in order to insert, you had to seek for the element which has to be inserted and at what location. Now here only deletion, because already array is existing, which element I have to delete. So that will be identified by the index. So I just consider the index location, which will be stored in the variable k or the identifier k. So now we need to perform this operation. We have to delete the element which is present at index location k. So now in this case, you have printed the elements. So it is all these elements which are present over here. Again, n is equal to 5, giving us the information that the array element is having, the array is having 5 elements. Now next, what you have done is, you are asking for the index location. So in this case, right, what they have done is, they have asked to delete the element which is present at index location 3. So index location 3 means you want to delete the element 22 from this array list, from this array elements. So now in order to perform that, you can observe that d is equal to array of k. So in this case, what it is array of 3. So what is array of 3? Array of 3 is 22. So you are just storing that value in a parameter which is identified with d. So just keeping this value, it is just utilized to print it, which element you have deleted. So it is utilized for that purpose. So you are storing the element which is present at the index location which is being deleted in the identifier d. Now what is the logical aspect? How you delete it? So again, you need to traverse through the array. Now previously we started off with the last element. Now here you can see that for I is equal to k. So in this case, I is equal to 3. You start off from that position. And what you're doing is, for I less than or equal to n minus 2. So n minus 2, in this case, it is equal to 3. In this case, it is equal to 3. So we'll just have a look at why this condition is utilized. So now what you're doing is, uh, previously what you had array of I plus 1 is equal to array of I, wherein you are increasing the index and storing the element. That was for insertion. Now what we have to do is, the next index element has to be stored in the previous index element. That is, here you can observe. So we wanted to delete the element which is present at index location 3. We had to delete the element from this position. So now what is the element which is present at A of 3? It is having the index of 3. So here it is like it is having an index of I plus 1. This has to be moved to the index location I. This has to be moved to index location I, which is nothing but, which is represented over here. So therefore what is done is, you can observe, for I is equal to 3, because we are just considering this element. I is equal to 3, I lesser equal to n minus 2. That is, it is 5 minus 2, which is equal to 3 over here. Then I plus plus, then we have array of I. So in this case, array of I, the first iteration, it will be 3. Array of 3 will be stored with the element which is present at array of 4. So here array of 3, previously it was 22. What is the element which is present at array of 5 plus 1? It is 77. So this element you are storing directly at this location. You're storing it directly at this location. Now next what happens is, I gets incremented. So I will be what? I will be 4 over here. Is 4 lesser than equal to 3? The condition fails. So therefore it comes out of the for loop. Now what you have done is, you have deleted an element from the array. So therefore what happens? You have reduced an element. So therefore you decrement the number of elements which is identified by n. You decrement the value of n. So this will give an indication that there are 4 elements present in this case. So therefore, what you have done is, you have deleted the element which is having the value of D and which is present at the index location K. Now here, if you just observe, again what we are doing is, we are printing this parameter. We are printing this parameter. Okay. So this is the program pertaining to array deletion. So let us have a look at it. Okay. Okay, we have the function over here. Sorry, this is the other one. Okay. So here we have the program to check out with these aspects. So I would like to observe what I would like to observe what is the value of I. N is anyways 5. D is the element which will be deleted, and K is the index. So I'll not worry about these parameters. I'll add a watch to observe what are the elements of the array. N is 5, then any other element which I have to add. So I'll just keep these two. Okay, I'll start the execution. So let us see how it goes around. So the array elements is being stored. So if I have to just check, so when I execute it, what we are having, we have the array elements which are stored in the name array. So in this case, I'm interested in I and the array values. So let us have a look at the next parameters. So n is equal to 5. So this value is fixed. Then you're printing the contents of the array. Okay. So now we need to just insert the index location from where the element has to be deleted. So now let us delete the element at the index location 2. That is array element 5 I want to delete. So I'll enter 2. Okay. So the index location is present in which this one. So here you can observe that K holds the index position of the element from where it has to be deleted. Now D will be holding the value of that element. So if you want, we can add the watch D. So D is equal to 5. 5 is actually the value which is present at index K. 5 is the value which is present at index K. So here we gave it what? 2. So index 0, index 1, index 2. So this is the element which is present at that position. So now what initially what will be the value of I? I will be equal to, so I will be equal to 2. I is equal to 2. So 2 is less than equal to 5 minus 2. That is the condition is true. That is 5 minus 2 is 3. 2 is less than equal to 3. Therefore, what happens is the element or the instruction gets executed. So in this case, what is happening is, so I is equal to k, that is this element. So now what we do is we shift all these elements one this thing towards its left, one index position towards its left. So now 22's index is identified by I plus 1. So which will be stored in index location I. So if you just observe this case, right, you can see that 22 gets stored in its index location immediately before it. So that is what is happening. So 22 is stored in index location, which is identified by 2. Now next, what we do is we need to I gets incremented and I will be equal to 3. So now when it is 3, so at this location, that is 3 is this location. This is 0, 1, 2, 3. So 3 is this location. At this location, you need to store the value which is present at index location 3 plus 1. That is 4. That is 77 has to be stored over here. So when I execute it, 77 gets stored over there. So now what we have 1, 3, 22 and 77. So if I had increased this, right, if I had made it as n minus 1 or n minus any other, then I would not be able to store these elements. That's why this condition is n minus 2. That is 5 minus 2. So up to that position, you need to identify, because here you can see that it is I plus 1. It is because of this condition, this parameter what you're using, this has to be stopped at n minus 2 and not n minus 1. It has to be stopped at n minus 2 since you are deleting it. So now you can observe that 1, 3, 22, and 77 are stored. Now, here we are indicating that there are 4 elements. That is done by decrementing the value of n. So n was 5. Now, after the execution of this statement, it will be equal to 4. So now this is what you will be performing. So it has printed the values. So after the deletion operation, you can observe that what all things are present. So array of 0 minus 1 is there, array of 1 which is 3, array of 2 which is 22, and array of 3 which is 77. So you can observe that element 5 which was present at index location 2 is being deleted. So this is the delete operation what we are looking into. Okay. So next, let us have a look at the next part. So this is pertaining to deletion of an element which is present in an array. So next, we look forward for sorting and searching operations. So what is basically sorting? So sorting in this one, what we do is we move or traverse through the array and try to rearrange those elements. So rearrange or shuffle the elements of the array based on some condition. Say I want to specify that the smallest number should come on top and the largest number should go at the bottom. So that is, the elements of the array should be in, say, ascending order, or it should be in descending order. So if I specify that condition, then you have to look forward for sorting of the elements which are present in the array. So how do we go ahead in this case? If I have to sort it, I have to compare each of the elements. So here we can see that so here we can observe. So if I am having an array of this kind and I want to sort these elements such that largest number 77 comes at the top and lowest number goes at the bottom. So in this case, what I have to do is I have to compare the pair of elements and then perform some operation. So this is again based on the logic what you will be looking forward. So you need to compare the elements which are present in the array and then go ahead with the sorting. So now there are different methods of sortings. So few are mentioned over here, that is bubble sort, merge sort, insertion sort, then you have selection sort, quick sort. So each of them has some advantages and disadvantages. So in the coming forth sessions, right, in later time period, we'll be discussing regarding all these sorting techniques. So there are sorting and searching techniques. So those will be looking forward, and what are the advantages, what are the disadvantages of these aspects. So that is what we will be looking forward. So in a present scenario, we'll be discussing regarding bubble sort. So what is actually bubble sort? So in this one, what is done is two consecutive elements which are present in the array are compared repeatedly and in this process what you are doing is you are moving the largest element which is present in the array towards the right. You are moving it towards the right. So basically what you are doing is you are moving the largest element and making it as the end of the that is the last element which is present in the array. So that is what you are looking forward. So largest element is brought at the end of the array in successive iterations. So you have to repeat this process unless and until the arrangement in the array is such that it is in the ascending order. So you are applying bubble sort for that purpose. So you compare two consecutive elements which are present in the array repeatedly, and then what you do is you move the largest towards the end of the array. And this you do until all the elements are sorted in the order. So here you can see that what they have done is the initial array is consisting of 5 elements, in which the elements are 5, 4, 3, 2, 1. So in the first pass, what is done is, in the first pass, what is done is 5 and 4 is compared. Two consecutive elements are being compared. So out of these two, which one is larger? So that one will be moved towards the right. So in this case, 5 is larger. So what happens is 5 moves at this position and 4 moves at this position, since 4 is lesser. So what happened? So in the first iteration, what we have, that is in first pass, under that first iteration, what we have 4, 5, 3, 2, 1. So this is the arrangement. So first two elements I had compared. Now I'll compare these two elements. I'll compare these two elements. So out of this, 5 is bigger. So I move it towards right. So what happens? So 5, this 3 will be shifted at this point. So it will be 4, 3. 5 will be present here, and 2 and 1. So again in the same first pass, next iteration, 5 and 2 will be compared. 5 and 2 will be compared. So now 5 is greater, so it will be moved towards right. So it will be 4, 3, 2 and 5, and it will be 1. So last, in the first pass, these two will be compared. These two will be compared. So what happens? This comes over here, and at the end of the first pass, you get to know that the largest element is bubbled down to the end of this array. Is bubbled down to the end of the array. So once you have done the first pass, no need to look at this value. This will be largest as compared to the previous one. So in the next pass, what you do is you again apply the same concept. You again apply the same concept. So this is the initial array. 4 and 3 is compared. 4 and 3 is compared. So 4 is larger, so it is moved towards right. So this continues. 3 will be here, and at the end, what happens? This is at the end of the pass 2. This will be the arrangement. So in this case, up to fourth pass, you perform this, and in 4 passes, you will be able to sort these 5-element array. So if there are n number of elements present in an array, you require around n minus 1 passes to sort the array elements. So you require that condition over here. So this is pertaining to bubble sort. So let us have a look at the program in which we look out for the bubble sorting. So again, these are the array elements. Then we have few of the variables or the identifiers which will be utilized. Here you are traversing and printing the elements. So next, this one is important for us. This one is important for us. So now what is happening? So as I specified, one pass, multiple iterations will be present. So after one pass, multiple iterations are possible. So in each iteration, we need to compare each of the elements. We need to compare each of the elements. So let us have a look at this. So these are the array elements which are present. So before sorting. So now here we are applying the bubble sort technique. So here we can see that we are having two for loops. The outer loop which is present is basically used to control the number of passes. Now, since we observed that if we have 5 elements, four passes will be sufficient. Four passes will be sufficient. And in the inner loop, we need to compare the elements. We need to compare the elements of which are present in the array. So now what we do is, so first we start off with the first this thing. So I is initialized to 5. I is initialized to 5, and we are checking the condition whether I is greater than 1. I is greater than 1. So 5 is greater than 1. So therefore the condition is true and this statement gets executed. So under this for loop, we have only this for statement under which we have all these statements. So next we have for j is equal to 0, j lesser than I minus 1. So if you just observe how many elements we are having, see if we are having 5 elements, we compare up to the last element. J is lesser than I minus 1. Now why this condition comes is, here we can observe that when we go through the first pass, the last element what we get is always a larger number. So no need to compare this again. So in the next iteration, in the first iteration, what we do is we compare all these 5 elements. In the next iteration, we compare the 4 elements. In the next iteration, we compare the 3 elements. In next one, we compare the 2 elements. And in last this thing, based on that, we'll be having this sorting. So as and when we move through the passes, right, the largest number bubbles down. The largest number bubbles down. So no need to, after this pass, no need to compare this one. This is anyways larger than the previous elements. After pass 2, these 2 elements are larger compared to the other elements. So no need to have a comparison over there. So again, the same logic. Now, even if you don't consider that and directly if you want to go ahead, right, even that is also fine. You can change this condition also. You can write it as I lesser, j lesser than say n minus 1, or j lesser than 5 minus 1. So here what you're doing, even if you keep this as j less than say n minus 1, so even then it is not a problem because anyways the numbers are sorted. So what they're doing is they're just reducing the number of instructions that are executed by putting this condition. So if you are if you know that already the last element which is there, it is already sorted, no need to compare. So you have reduced what, say, one execution instruction. Similarly here two already elements are being sorted, so only these 3 elements have to be sorted. So you are reducing the number of instructions, so you are reducing the overhead over which is present over there, so by just putting this condition. So if you're dealing with embedded systems, right, that time these all things become critical. So when you're doing programming, right, you generally try to look into these features, that you try to reduce the number of lines of code. You try to reduce the memory space which is being consumed by a program. You try to reduce the amount of time it takes to execute. So these are just simple ways of doing it. So here, this is for the number of passes, and this one we can observe j is equal to 0, j less than I minus 1, that is 5 minus 1, and j plus plus. So this is for the inner loop. That is, you are comparing element by element within each passes. So here what we had, so initial array was 5, 4, 3, 2, 1. Now this is given as input to this case. Now in the first pass, you pass on. So j is initially 0. Now what you do is you compare these two elements, 0th and the first element. So that is what you're doing over here. If array of j, that is in the initial this thing, it is array of 0 is greater than array of 0 plus 1. That is, if element 5 is greater than element 4, what you have to do, you have to swap these two. You have to put 4 over here and 5 over here. So that is what you're doing over here. So here you store one of the elements in the temporary variable. So in this case, what they are doing is, so as per this case, if I just observe array of 1, so 4 is stored in the temporary variable. So this one is free. So in this one, what we are doing is we are storing array of 0, which is 5. So here 4 is stored in the temporary variable and 5 is stored in this location. Now this is free. So now what we do is in this location, I store the value 4. So using temp variable, we are swapping these two values. We are swapping these two values if the condition is satisfied. If the condition is not satisfied, no need to perform any operation. Say for example, if this was 4 and this was 5, when I compare, uh, if this is the case, when I compare this element is 4 and this element is 5, whether this condition satisfies? No. Since this condition is not satisfying, this statements will not be executed. And already you can see that the largest element is present towards the right of these two. It is present towards the right of these two. So no need to perform the swapping operation. So now next what we have, still we are in the inner loop, j is incremented by 1. So now in the first iteration, what we have, these two are interchanged. So we have 4 here, 5, and remaining will be as it is. Remaining will be as it is. So now j is incremented. When j is incremented, j value will be 1. So array of 1, eh, whether this is greater than array of 2, that is 1 plus 1, 2. So what is array of 1 in our case? That is, this is the new set which is there. So it is 5. 5 is compared with array of 2, that is the element 3. So 5 is greater than 3. The condition is satisfied. So again, swapping happens. So in this case, this one is stored in the temp variable. This one, since this value is already there in the temp variable, what they do is they store 5 at this location, and this temporary variable comes and sits at this location. So you have interchanged them. So this process continues till all the elements are swapped in the first iteration. That is, in the first pass, in the first pass, in the first pass, you get this result. You get this result. Now that is the inner loop condition. Once it fails, right, what happens is this for loop will be executed, which will be I minus minus. So previously it was 5, it will be 4 now. So is 4 greater than 1? True. So now again you go in and perform the same operation by checking whether the elements are satisfying the condition or not. So this you continue till all the elements are sorted. Till all the elements are sorted. So now let us have a look. Okay. Okay. Okay, we have it over here. So we'll try to run this program. So we'll have a add watch to y. We'll add a watch. Okay. So I have added watches to I, J and array elements. So now what we have the array elements which are present in 5, 4, 3, 2. So let us see what is happening. So we'll add watch even to the debug, temp variable. So let us see what happens. Okay. So we are printing the elements of the array. So it has been printed. Sorry. Okay. So what else? So now we have so now what we have I is equal to 5. So we enter the loop. Then we have for j is equal to 0. So j is initially 0 and 0 is less than 5 minus 1, which is 4. Condition is satisfied. Now what is array of 0? Array of 0 is 5 and array of 1 is 4. So this index is 0, 1, 2, 3, 4. So now whether this condition is satisfied, if yes, then you can observe what happens in these cases. So you can just see now temp variable will be stored with array of 1. So because it is 0, 0 plus 1, that is 4 will be stored in temporary variable. So 4 will be stored. So 4 is already saved. Now what we do is we store 5 at this location. We store 5 at this location. So here 5 is stored. Now temp variable is holding this value, is holding the value that was previously present, which is 4. So now what we do is we store that value in this location. So you can see that in the first iteration, it is 4, 5. These two elements are swapped. These two elements are swapped. So that is largest element is moved towards the right. Now, similarly, next what we have to do is we have to compare 5 and 3. We have to compare 5 and 3. So now what we have over here, we have j is what? J is 1. It has been incremented. Is 1 less than 5 minus 1? Since I is still 5. It is 5 minus 1, 4. It is true. So now I compare. What is j? J is 1. So array of 1, is it greater than array of 2? So array of 1 is 5 and array of 2 is 3. Is it satisfying that condition? Yes, it is being satisfied by the condition. So therefore what happens is these two numbers have to be swapped. So the operation is performed in this case. So both the numbers get swapped. So this process will continue till the last element in this case. So you can observe 5 keeps on doubling down. So it is like bubbling effect. So now this has completed the first pass. Now you can see that I is decremented. First pass is over because this condition fails. Therefore it goes and decrements I. So when I is decremented, I turns out to be 4. I turns out to be 4. So now when I is 4, when I is 4, whether 4 is still greater than 1? Yes. So therefore what we do is we go inside the loop and again j will be starting from the 0th element. Now here you can see that j is equal to I minus 1. That is 4 minus 1. Previously it was 5 minus 1. I specified why we are doing it. So already the last element, that is this element 5, is already the largest element which is sorted. Now we need to compare only these 4 elements. These 4 elements. That's why you are having this condition. That's why you are having this condition. So it will be like 0, 1, 2, 3. So up to this thing, you will be comparing it. Only these 4 elements you will be comparing in the next pass. So therefore, what you have, you compare whether, so in the first iteration, whether 4 is greater than 3. If yes, then you swap it. So that is what you are doing over here. So swapping happens. So again, J keeps on incrementing. And what happens is, so you can see that J is equal to 2. In this process, the swapping has happened. Now what happens is the condition fails. The condition fails. J is 3. 3 is less than 3 minus 1, 2. The condition fails. So therefore you come out of that loop and you decrement I. I is 3 now. So now these two are what are being sorted. Now we have to sort the remaining. We have to sort the remaining. So how many elements are there? There are 3 elements. So that is what I minus 1 is dealing with. So this we keep on continuing. You can see that in the iteration, it keeps on. So sorting has happened. So these are the elements which are being sorted. So this is with regard to sorting of the elements using the bubble sort. Using the bubble sort. So this is all for this session. We'll be meeting in the coming 4th session, in which we'll be discussing regarding the searching methods. Okay. Yeah. Thank you.